Lesson 5-4 Graphing Linear Equations, and in this lesson you'll learn to graph linear equations. Okay, why is it important? You can graph linear equations to solve problems involving health and physical science, and let's take a look at this example in health. The manner in which you burn calories depends on your weight and the activity you are doing. The chart at the right shows the number of calories burned per minute per kilogram. Manuel weighs 70 kilograms and wants to know how many calories he burns playing football. The formula C equals WTR, where W is the weight in kilograms, T is the time in minutes, and R is uh, C per minute per kilogram, okay, can be used to determine how many calories he burns. Okay, so let's take a look at the chart at the right. In basketball, for example, he burns 0.138 calories per minute per kilogram. Cycling, leisure cycling, that's 0.064 calories per minute per kilogram. And racing, higher than that, obviously, will be 0.169 calories per minute per kilogram, and so forth and so on, all the way down the line. Okay, and then you have here sitting quietly 0.021 calories per minute per kilogram, and just typing on your computer will be 0.027 calories per minute per kilogram. Okay, football, where's Manuel's sport, it's 0.132 calories per minute per kilogram. So that's how much uh, calories per minute per kilogram each of these sports burn. Okay, and let's take a look at the formula C equals WTR. Okay, now if we get Manuel's weight, which is 70 kilograms, and uh, the time, we don't know the time that Manuel will be playing football, and the calories that he burns, okay, are calories per minute per kilogram that the Manuel burns would be 0.132. That's football right over here. Okay. So if you notice, and we simplify this particular equation, we have C equals 9.24 T when you multiply 70 times 0.132. Okay. So the number of calories burned is dependent on how long he exercises. So T is the independent variable and C is the dependent variable, just like what we talked about in relations. Okay, so C will depend on the time that he plays footballs. So C is your dependent variable, T is your independent variable. And if you also remember, time is always independent, and that is your T. Okay, and that's another way of finding out what is your independent and dependent variable. Time will always be independent. Okay, so the number of calories burned is dependent on how long he exercises. Okay, and we talked about that T is an independent variable and C is the dependent variable. Okay, and if we look at or we let's say Manuel plays football for 0 minutes, obviously the calories that he will burn will be 0. So therefore your ordered pair will be 0 and 0. Okay, if Manuel plays for 10 minutes, it will be 9.24 times 10, and that would be 9.92.4. So your ordered pair would be 10 and 92.4, which simply means for every 10 minutes that he plays, he burns 92.4 calories. Okay, and we do that for 20 minutes, substituting the equation 9.24 T. Okay, Manuel burns 184.8. So for every 20 minutes that he plays football, he burns 184.8 calories. For 30 minutes, we follow the same process. Manuel burns 277.2 calories if he plays 30 minutes. And for 40 minutes, Manuel burns 369.6 calories. So for every 40 minutes that he plays football, Okay, he burns 396, or sorry, 369.6. Okay, now a little bit FYI on calorie. When you talk about calories, okay, in science, a calorie is defined as the quantity of heat needed to raise the temperature of 1 gram of water 1 degree Celsius. So that's another way of looking at the definition of a calorie. It's actually, okay, the heat needed to raise the temperature of 1 gram of water 1 degree Celsius. Okay, the word calorie that we use when referring to food actually, okay, refers to kilocalories or 1000 calories. So whenever we refer to calorie, we're actually referring to kilocalories or 1000 calories. These are referred to as calories with a capital C to differentiate them from the thermal unit, which is a lowercase c. And that's the reason why our C is always capital. Okay? A little bit of a FYI if ever you join Jeopardy. That's one question you can answer right there. Okay? So if we graph, okay, what we have on this table, this is what we're going to get. Okay? We graph all the ordered pairs in this area. That's what we're going to get. That's the graph of our table, where your horizontal variable represents time, your independent variable, and your vertical axis represents your dependent variable or calories burned. Did I say horizontal variable? It's supposed to be horizontal axis. Anyway, okay. So when you graph the ordered pairs, a pattern begins to form. The points seem to lie on a line. Okay? And let's suppose the domain of C. Remember what domain is. It is the values of your independent variable. Suppose the domain of C equals 9.24t is a set of real positive numbers. Remember, you cannot have a negative, okay, for this one because it won't make sense. There would be an infinite number of ordered pairs that are solutions for the equation. So basically what it's saying is this. If you replace C with a set of real, T with a set of real positive numbers, there will be an infinite set of solutions. If you graphed all the solutions, they would form a line. Okay? So basically what happens is that if I get points in between these lines, they will also be true for that particular equation. So if you graph that and connect those, you'll form a line. Okay, the line shown in the graph at the right represents all the solutions for C equals 9.24t. What it's saying is that every single point on that line, okay, will make the equation C equals 9.24t true. Okay, and since it forms a straight line, okay, we now call this a linear equation. Okay, since the graph of C equals 9.24t is a line, C equals 9.24t is called a linear equation. Okay, so that's how we define a linear equation. We define it more in the next one. Linear equations may contain one or two variables with no variable having an exponent other than 1. This definition right here is probably as important as the definition that we see in the linear equation in standard form. Okay? So when you talk about the linear equation, may contain one or two variables with no variable having an exponent other than 1. And this brings us to the definition of a linear equation in standard form. A linear equation is an equation that can be written in the form of ax plus by equals c, where a, b, and c are any real numbers, and a and b are not both equal to 0. Okay? So when you talk about a linear equation, this is a linear equation in standard form. And if you notice, A, B, and C are all capital letters, okay, because A is the coefficient of X, okay, B is the coefficient of Y, and C is your constant, okay. So any real numbers A, B, and C, okay, are not both equal to 0. and at the same time we can add on to the definition of a standard equation that a, okay, should be greater than or equal to 0. So at this point, we'll add that particular definition. But when you go to high school, you learn something probably a little bit more than that. For now, we know that a should be greater than or equal to 0. Okay? Let's take a look at example number 1. Okay? Determine whether each equation is a linear equation. If so, identify a, b, and c. So we have 4x equals 7 plus 2y. Okay? So first, we need to write the equation so that both variables are on the same side of the equation. How do we do this? Okay, let's copy the problem. Okay, 4x equals 7 plus 2y. And then we need to subtract 2y to each side of the equation. Okay, and if we subtract 2y to each side, we end up with 4x minus 2y equals 7. Okay, so now we have ax plus by equals c. So in this case, okay, the equation now is in the form of ax plus by equals c, where a is equal to 4, b is equal to -2, and c is equal to 7. This is a linear equation. Okay, now you may ask, it's 4x minus 2y equals 7. Why is it in the form of ax plus by equals c? Well, if you notice also, you can write 4x minus 2y equals 7 to be 4x plus -2y. Sorry, let me redo that because it has to be inside the parentheses. It would be 4x plus -2y equals 7. And that's the reason why 4, or a is equal to 4, b is equal to -2, and c is your constant, which is equal to 7. Okay? And going back to the definition of a linear equation, it says that no variable having an exponent other than 1. And if you notice, all the exponents of all the variables, okay, all the exponents are equal to 1. Okay? Let's take a look at letter B. Okay? If you notice, you have 2x squared, and x is raised to the second power. So the exponents of the variables in a linear equation must be 1. Okay? Since the exponent of x is 2, this is not considered to be a linear equation. And let's take a look at letter C, which is x equals 12. Okay? Okay, if I rewrite this x equals 12, we can rewrite this to be as x plus 0y equals 12. Okay, where a is equal to 1, b is equal to 0, and c is equal to 12. Therefore, it is a linear equation. Okay, so in the form of ax plus by equals c. So remember this, when you see this, this is in the form of ax plus by equals c, because a is equal to 1, okay, b is equal to 0, and c is equal to 12. Okay? Moving on, to graph a linear equation, it is often helpful to make a table. Okay? It is often helpful to make a table of ordered pairs that satisfy the equation. Okay? Then graph the ordered pairs and connect the points with a line. Okay? So we're asked to graph in example number 2, y equals 8x minus 12. So what we want to do, okay, to be able to graph 8x minus 12 is we need to select 5 values for the domain and make a table. Remember, our domain is x, okay, our range is y. Therefore, y is dependent on x. X is our independent variable. Y is our dependent variable. Okay, and then graph the ordered pairs and connect them to draw a line. So we choose any 5 values of x. Any 5 values will do. Let's choose these 5. -2, -1, 0, 1, 2. You can choose any values you want. These are probably the easiest values that you can work with to make your math easier. So we have 8x. We should substitute 8x negative 2 to x in 8x minus 4. You have 8 times negative 2 minus 4. Okay, the value of that will be negative 20. So your ordered pair will be negative 2 and negative 20. We do the same for negative 1. The result for y will be negative 12. Our ordered pair will be negative 1 and negative 12. Okay. We do the same for 0. So this becomes 8 times 0 minus 4. Okay, we'll give you a value of 4. Your ordered pair becomes 0, negative 4. Do the same for 1. Our value for y is 4. Ordered pair 1 and 4. For number 2, 8 times 2 minus 4 will give us a value of y. That'll be 2 and negative 12 as our ordered pair. And if we graph, okay, this, okay, you can see that you can find other ordered pairs, okay, that are solutions to the same equation, such as 25 and 16. And if you look at 25 and 16, or sorry, 2.5 and 16, 2.5 is right here, okay, 16 is right there. So that is a solution because now 25 and 16, or sorry, I'm going to keep on saying 25. 2.5 and 16 right here, okay, will lie on the line. Any point that lies on the line will be the solution to y equals 8x minus 4. Okay? So the range of the relation is the set of real numbers. Okay? Let's take a look at example B in this case. And example B. Why is it covered? I don't know why it's covered. It's 2x plus 5y equals 10. You're asked to graph 2x plus 5y equals 10. And in order to do that, what's the first thing we need to do? Okay, you don't want to be solving that equation 2x plus 5y equals 10 and then always solve for the value of y. That will be too cumbersome. So what do we need to do? So in order to find values for y more easily, okay, we need to solve for y. Okay, so let's copy the equation 2x plus 5y equals 10, and we need to solve for the variable y. Remember what we did in formulas in that lesson? We need to undo 2x, okay, and if we undo 2x, we subtract 2x to both sides. You end up with 5y equals 10 minus 2x, subtracting 2x from each side. And then we need to isolate y by dividing both sides by the number 5. So end up with y equals 10 minus 2x plus 5. Divide each side by plus 5. Now it's a lot more manageable. So every time we find the value of x, we can easily find the value of y because of what we did in solving for y. Okay, so now make a table and draw the graph. Okay, so again, any 5 values of x. Now, are you limited to 5? No, you're not. Okay, 5 will make sure that you will get a straight line. So if you get 5 values and this forms a straight line, then more or less what you're doing is correct. Okay, so 5 points on the line will ensure that you are going to get a straight line from your linear equation. Okay, so let's try these 5 values, negative 10, negative 5, 0, and 0, 5, and 10. Why is that? Okay, and the reason why you want to use these, you can use any value you want. You can use negative 1, negative 2, 0, 1, 2. Okay, you can use negative 0.5. So it doesn't really matter what value you use. The only reason why these values are used, okay, simply because your denominator is 5. And if you use these values, 0, 5, and 10 are multiples of 5. Okay, and if you use these values, you'll end up with a whole number. And that's exactly what we have. If you substitute negative 10 to that particular expression, you end up with a value of y is 6. Your ordered pair is negative 10, 6. Okay, negative 5 will give you a value of 4. Ordered pair will be negative 5, 4. 0 will give you a value of 2. It's going to be 0, 2. 5 will give you a value of 0, end up with an ordered pair of 5, 0. 10 will give you a value of negative 2, ordered pair of 10, negative 2. And what do you do after that? You simply get your, okay, these ordered pairs right there, not including, of course, xy, and you begin to graph your ordered pairs. Okay, after that, connect them with a straight line, and that is the graph of the equation 2x plus 5y equals 10. Okay? Okay, using graphs is a good way to make comparisons in real life situations. Okay, so let's refer to the connection at the beginning of the lesson. Okay, Carmen Delgado is running in a cross-country meet at the rate of 5 minutes per kilometer. Her weight is 50 kilograms. How does the number of calories she is burning compare to those that she would be burning if she were at home word processing her research paper, or if she were playing golf with her dad? So we want to compare the number of calories that she would burn doing those different activities. So look at the calories burned for each of the three types of activities: playing golf, word processing, and what's the other one? Cross country, running cross country. Okay, so this is on chart page 280, so I would not flip my slide here, but you can flip your book, go back to your to page 280, okay, and look at the number of calories per minute per kilogram burned for each of those activities. Then write an equation for each activity using the formula C equals WTR. Again, W is your W is your weight, T is your time, and R is calories per minute, calories burned per minute per kilogram. Okay? And 50 for W because that is her weight. Okay, so let's look at running. So running, her weight is 50 calories per the calories per minute per kilogram burned for running is 0.208. Multiply that by T, end up with equation 10.40. Okay, word processing, okay, 50 times 0.027T, you end up with equation 1.35T. Okay, and you have golfing, okay, 50 times 0.085T, or equal to 4.25T. Okay, now if you use a graphing calculator, okay, so using a graphing calculator to graph all three equations, okay, we want to know that enter y1 and y2 and y3 represent x represent the t in each equation, and make a sketch of each graph and label each with its activity. Remember, y1 is your c, simply because y1 c is your dependent variable, and x represents your t because t represents your independent variable. So if you use a graphing calculator, or if you simply downloaded GeoGebra and typed these equations, c equals 10.4t, c equals 1.35t, and c equals 4.25t, this is what you're going to end up with. Okay, so you have word processing. Okay, we'll give you a line. We'll give you a line. Let me get a nice line here. This is probably good. Okay, this line right here. There. Okay, and we'll do red. Red's a good color. Okay, so if you look at word processing, this should be straight now, because what's going to happen is that, okay, once you do this in GeoGebra, it's going to be straight. This is a very old graphing calculator, and that's the reason why the line is very pixelated. Okay, so golfing, okay, enter that particular equation, that's your line, and running, enter that particular equation, that would be your line. Okay, now after that, you analyze what you have, okay, and For each value of t, Carmen burns many more calories running than she does golfing or word processing. Carmen would burn more calories golfing than she would word processing. Not a genius to find that out. Okay, so think about the physical movement required for each activity and how much energy that would take. Does the result make sense? Obviously, it does. Okay, so looking at these linear equations, you know that running burns most calories because the change in y, okay, over the change in x is greater than the change in y over the changing in x in golf or word processing. Okay, and that's the end of our lesson on linear equations. Thank you for watching.